All right, let's talk about something you hear all the time after a plane crash, pilot error. But what if that's not the end of the story? What if it's not even the right place to start? Today, we're going to dig into why that common phrase might be pointing us in completely the wrong direction.
You know the old saying, right? To err is human. We all get it. We accept it. I mean, who hasn't sent an email to the wrong person? Or, walked into a room and completely forgotten why you went in there? It's how we're wired. But here's the thing. The moment we start talking about aviation, all that understanding for human mistakes just vanishes. Suddenly, for the person in the cockpit, 30,000 feet up, we expect them to be superhuman. We expect perfection. No mistakes, not for a single second. It's an impossible standard, really. So that brings up a really big question, doesn't it? When something goes horribly wrong, who's really at fault? Is it the human for just, being human? Or is it the fault of the system for not being designed to handle a normal human being in the first place? Is it really pilot error, or should we be calling it design error? And that is exactly what we're going to dive into. We're going to challenge that whole pilot error narrative. Because blaming the human often means we're totally missing the real underlying problem. And this is not some small issue. Get this, around 70% of all aircraft accidents are blamed on pilot error. Think about that. Even with all our incredible modern technology, that number has barely budged for decades. Something's not adding up here. Okay, so there's this fantastic analogy from a NASA report that really makes this click. Imagine you build this super powerful computer, but you forget to put in a cooling fan. So what happens? It overheats. It crashes. Now, would you blame the computer for getting hot? No way! You'd say it was a design flaw, right? So why don't we do the same thing for pilots? We know humans have limits. So why do we build systems that push them past those limits and then blame them when things go wrong?
This whole idea leads to a massive shift in how we think about design. We have to move away from a technology-first mindset to a human-first one. It's simple, really. You build the machine to fit the person, not the other way around.
And you can see the difference in the questions they ask. The old way, the tech-centric way, just asked, hey, can a person physically push these buttons and pull these levers? But the new, human-centered way asks a much smarter question. Is this the right way for a human to do this? Is it intuitive? Does it make sense when you're stressed and time is running out? See the difference? It's huge. And this all boils down to one core principle, something aviation experts have been saying for years. The human pilot must be in command. And that doesn't just mean they can hit an off switch. It means they have to know what the automation is doing, why it's doing it, and what it's going to do next. The tech is there to help. It's a tool. It is not the boss.
So this new philosophy has a few clear rules. Rule 1, the pilot is in charge, period. Think of the automation like a royal servant. It's incredibly capable, but it does what it's told. Its job is to handle all the boring, tedious donkey work, so the pilot can focus on the big picture. And the whole thing starts with one basic acceptance. Humans aren't perfect. We have limits.
Okay, so this all sounds great on paper, right? But what does it actually look like when you put these ideas into practice? What does a cockpit built for a human being actually feel like?
So let's take a look. I want to show you a couple of really cool innovations that came out of a huge research project on this very topic. Check this out. This is a 3D terrain view. So instead of staring at abstract lines on a screen, the pilot gets a virtual window showing them exactly what the ground looks like outside. Even if it's pitch black or they're in the middle of a storm, they can literally see the mountains coming up. It's a massive boost for what they call situational awareness.
Okay, now for this one. One of the trickiest things for a pilot is figuring out what the heck the autopilot is doing. Usually, it's just a bunch of confusing text on a screen. But this thing, the graphical enunciator, totally changes the game. It uses simple things, color, shapes, where things are on the screen, to tell the pilot exactly what's going on. So instead of squinting at text, the pilot just glances. Is the plane climbing? The display shows it. Is it turning? The display shows it. Who's flying the plane, me or the computer? It's all right there, in an instant, clear as day. A simple visual tweak like this makes it so much harder to get confused about what the automation is doing.
So, the big question is, does any of this stuff actually work in practice? Well, let's look at what happened when they put real pilots in simulators with this new tech. And the results were amazing. Seriously, the pilots in the tests had much better situational awareness, they knew what was going on around them, and at the same time, their mental workload went down. Let me say that again. They understood more while having to work less.
I mean, that is the absolute dream for anyone who designs anything.
And really, that gets us to the heart of it all. The goal here isn't to try and build a perfect pilot who never makes a mistake. That's impossible. The goal is to build an error-proof system, a system that knows humans will be humans and is smart enough to catch those small, normal mistakes before they can turn into something catastrophic.
So I'll leave you with this. If we can totally rethink something as complex as a cockpit to make it work with our human nature instead of against it, it kind of makes you wonder, right? What else in our world desperately needs that same kind of human-centered thinking? Think about the software you use every day, or the equipment in our hospitals. Where else are we blaming the user when we should be blaming the design?